Mark, we're here at Trinity College in Dublin. Can you tell me a little bit about what you do here?
Yes, so I'm a postdoctoral researcher here in the Additive Research Lab. So I'm working with companies to look at different ways of producing 3D metal printed parts.
And when you say 3D printed parts, is that mainly for any particular sector, for instance?
So it can be in a range of different sectors, but for me personally, the work I'm doing is particularly it's in the biomedical sector.
And I see today, principally, we're here with Warwick Machine Tools, who sold you this wire Excetek machine. Now, how does that work in reference to the 3D part?
Yeah, so when you 3D print the parts, you're printing them directly onto a build plate, so you're melting the part directly onto the build plate itself, so it's securely attached. So for us, we needed a tool that could remove these parts from the build plate in a clean and also precise manner. So for us, the EDM, the Excetek, was a really good choice because it's a non-contact cutting method, so we could reduce some lightweight parts without actually damaging the parts themselves. So it's a really nice piece of equipment.
And is EDM, in your experience, the only way to actually sort of take these parts off the build plate?
Yeah, if you're wanting to produce remove parts which have these lightweight structures, so lattice structures, you can't use typical methods just because of the cutting forces. So for us, EDM was the only choice.
And why did you specifically opt for the Excetek machine from Warwick Machine Tools?
So we did a full tender process and they won out. So in particular, they had some very good support here in Dublin. So having that sort of direct contact and kind of quick support time, that was really important to us.
And from a personal point of view, how easy is it to use with the controls that you've actually got here?
Yeah, it's really intuitive. So the control panel is fully touch screen. It's well explained, and then you have a kind of a wide range of actual features on the controller that you can use, and then additional features like your auto wire feeding. So if there is breakage, you don't have to worry about trying to rethread it. So like that makes it very, very easy. You can set it up and walk away and continue on with your research, which is very nice. So we're very happy with it. It's been running consistently since we've got it, and the service engineer has been there to give us support when needed. So it's been very, very enjoyable so far.
Richard, you're in charge of this laboratory actually at Trinity College. Can you tell me exactly what you do here?
Well, I'm the lead engineer for the lab. I procured all the equipment here. We have about 4.3 million euros worth of equipment in 100 square meters of space. We have 6 or 7 pieces of kit in this space across 5 different technologies, going from printing inks, our bespoke nanomaterial inks that are fabricated up in the main institute about a quarter of a mile away from here. We also have a couple of polymer 3D printers that use light to print polymers in 3 dimensions. We have the only ceramic 3D printer in Ireland here, which is a unique spec worldwide. But cream of the crop are our 2 metal printers just behind us, which are used in conjunction with the Excetek 400.
And what type of work are you actually doing here?
So the lab is actually set up to do material science for additive manufacturing. So AMBER stands for the Advanced Materials and Bioengineering Research Centre. The clue's in the name. The material science for bioengineering. We also do material science for printed electronics. We have a couple of very large clients who are biomedical clients and IT clients. Ireland is a major biomedical hub, for example. Our biggest client is actually very interested in printing titanium parts for use as implantation. We have links with the Trinity Biosciences Institute further up Pierce Street here. And within that, we're funded to do some research into the next generation of implants. So that the idea behind that would be printing a titanium core and on the outside of that, printing your own biological material, so your own stem cell grown material around that titanium core. Printing titanium is quite a challenging process. Titanium is a very strain sensitive material, and it needs to be very carefully heat treated after we print that. Part of the problem is, how do you remove a titanium part from a base plate? How do you do it gently and in the right order? That's why we have the Excetek tool here.
And Paul, now you've been involved with this purchase of the Excetek machine. Can you tell me exactly why this machine and what benefits it offers to Trinity College?
Well, this machine is quite a flexible machine. It's very easy to use, so we can have many different operators can quickly learn the process and jump on. And the other thing is its ability to be able to measure the base plate on the machine and then orientate the axis virtually of the machine along that plane, which makes things very easy. People can just pop a base plate on, it'll probe itself, align itself up. So gone are the days of using a clock to do that.
And is there no other way of actually removing the material from the base plate?
No, if you want to retain the integrity of the workpiece, then spark erosion at the moment is the only way to be doing it. It doesn't damage the piece that you're cutting off, and as well you're able to profile along any details that the guys may have created, and you couldn't really do that with just a simple bandsaw.
So the benefits to Warwick Machine Tools is that you're not only selling machines into general manufacturing, but also you're working with the likes of Trinity College and also other universities around the UK.
That's right, indeed. In fact, the machine we've got here, we've been involved in additive manufacturing with many institutions for some time now, and we've managed to develop a technology which can cut various materials which have been additively created to overcome such issues as powder inclusion, which can present problems for this type of technology. So we've worked very hard to overcome that.
And Richard, from the process of actually working with Warwick Machine Tools and what you're achieving here, could you sum that up to us?
Well, I think the most important thing to say about that is we have a full value chain now. So we have the capability here to do the material science. We have the capability now to do research in that material science and build bespoke parts for our research partners. And we also have the capability to isolate those parts, remove them from base plate, and continue to do non-destructive and destructive testing in our adjacent labs next door. So this particular piece of kit is a fundamental part of that chain.